Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss types of redox reaction. There are different types of redox reactions. As for example, combination reaction, displacement reaction. In this displacement reaction, there are two types: metal displacement, non-metal displacement. And next is decomposition reaction. Then various types are there. I will discuss one by one. One more this reaction is there, redox reaction. That is the disproportionation reaction. Disproportionation reaction. Then these are the important, you can say, types of redox reaction. Last class I have discussed many things about oxidation, reduction, oxidizing agent, reducing agent. Now I am going to start types of redox reaction. A combination reaction. First is the combination reaction. I am going to talk about combination reaction. By name itself, it is clear, combination. A combination reaction may be denoted by like A plus B, that will give C, means addition. Combination means addition. Either, suppose in general A plus B, it will give product C. Okay. Either A and B or both A and B must be in the elemental form for such a reaction to be a redox reaction. Means A and B, both, either A or B or both A and B may be in elemental form. All combustion reaction which make use of elemental dioxygen, means oxygen, as well as other reactions involving elements other than oxygen, okay, are redox reaction. Again you listen, all combustion reactions which make use of oxygen as well as other reactions involving elements other than oxygens are redox reaction. Important just examples I am telling you. Carbon plus oxygen, it will give CO2. After heating carbon and carbon, if you will heat in presence of oxygen, it will give carbon dioxide. Okay. Second example, magnesium plus nitrogen. It will give Mg3N2, magnesium nitride. Mg3N2. This is important reaction also. Third reaction means third example, CH4 plus 2O2. It will give carbon dioxide plus water. CH4 means methane plus oxygen. It will give carbon dioxide plus 2H2O. These three examples what I told you, all are the examples of combination reaction. And generally all combustion reactions which make use of elemental dioxygen, means O2 you can tell, as well as other reactions involving elements other than oxygen are redox reaction. Here, how can you tell it is a redox reaction? Then first example I told you, C plus O2, CO2. Okay, after heating carbon plus oxygen, carbon if you will heat in presence of oxygen, it will form carbon dioxide. Then how will you tell this is the redox reaction? What is the proof? Then see, here already I told you, in elemental state, atom has zero oxidation state, and all gases, oxygen, chlorine, bromine, iodine, like this which exist in the elemental form, all have zero oxidation state or zero oxidation number. Then here, if you will write the reaction C plus O2 CO2, then C carbon is in elemental state, hence oxidation number is 0. O2, it is gaseous state, it has also oxidation state 0. Then now product is CO2. Then now if you will calculate, last class I already discussed in details how to calculate oxidation number. Now CO2 is there. Then how will you calculate? You can say oxidation number of carbon in CO2. Then here it is very easy, already I told you last class. Then CO2, then oxygen has two oxidation number. Oxygen has two oxidation number. Then CO2, 2 oxygen is there. Then it means total oxygen is -4. 1 oxygen -2. Then here 2 oxygen is there, is -4. Then in CO2, finally CO2 total, if in any molecules, if nothing is written in the molecule, no charge is given, neither positive, negative, it means it is the 0. It means it is 0. Then here CO2, then C you have to calculate, and CO2, the C you have to calculate the C plus O2. What is the value for O2? -4. 1 oxygen -2. Then 2 oxygen -4. Then C plus O2. O2 means here -4. That is equal to 0, because in CO2 no charge is written, neither negative nor positive, nothing is written. It means 0. Then C plus, in bracket you have written -4, means 2 into -2, that is -4. That is equal to 0. Then now you solve it. What is the value for C? Then C -4 is equal to 0. C -4 is equal to 0. It means C is equal to 4 plus 4. Correct? C plus in bracket 2 into -2, that is equal to 0. Then 2 into 2 minus 2, that is -4. And outside the bracket also plus is there, so plus minus minus only. Then C -4 is equal to 0. Then C is equal to +4. Hence oxidation number of carbon in CO2, that is the +4, and oxygen -2. Already you know. Per atom you have to write per atom, not the total -4 like that. That is for calculation purpose. Oxygen has oxidation number -2. Then in CO2, carbon has +4 oxidation state, oxygen has O2, oxygen has -2. Then now you compare reactant molecules and product, you compare. Then C plus O2, then C was having 0 oxidation state in reactant side, but in product in CO2, carbon has +4. Then now carbon, which was having 0 oxidation state, now it is a +4. It means carbon has lost 4 electron. That's why it became +4. Then here there is a change of oxidation number. There is a change of oxidation number. Hence you can tell this is the redox reaction. Now other also you can compare O2. Reactant side it was O2 which has a zero oxidation state, but in CO2 it became a -2. Then here what happened? That now oxygen has a lost 2 electron. Oxygen has a lost 2 electron. O2 was 0 in the reactant side. 0. Now it became -2. But here 2 oxygen was there. Then total change, total you can say this -4. Carbon has lost 4 electron. Who have taken this 4 electron? Then this oxygen which was 0, C plus O2, O2 was 0, then this carbon has lost 4 electron. Who have taken this 4 electron? Then this oxygen. That's why now it became product side total -4, but one oxygen you have to write what is per atom, that you have to write you can say charge sign, then -2. Then here if you compare, then oxygen O2 was having 0, and now right side in product in CO2 molecule now it become -2. Then here again there is a change of oxidation state or oxidation number. That's why this reaction is redox reaction. Okay. Now you can see other example. I have given 3 example. All 3 I am discussing. First one I already told. 3 Mg plus N2. It is giving Mg3N2. Magnesium nitride. After heating magnesium, if you will heat with nitrogen, means N2, it will give Mg3N2, magnesium nitride. Again, same way you can compare magnesium, that is elemental state. Balance equation first write, but here in calculating oxidation number, that this is stoichiometry, means coefficient is not has value. Stoichiometry means coefficient has no value in calculating. Only molecule has importance. O2, Br2, Cl2. In molecule, how many atoms are present? Different atoms. That is important, not the coefficient. Okay, but here you have to write balanced equation. Okay, because product will form. How product will form? Mg3N2 means 3 magnesium is required. Then balance equation first you should write. After that, but for calculation purpose, only molecule you calculate. Then 3 Mg plus N2, Mg3N2. Then now Mg is an elemental state, means 0. Reactant side, magnesium in the beginning it is a 0 state. Nitrogen N2 gas, again it is also 0 state. Both are 0 state. But product side Mg3N2. It form Mg3N2. Then now magnesium, I told you, all you can say group 1 elements, all group 1 elements that has +1 oxidation state. All group 1 element, and group 2 they have +2. Okay, group 1 element is called alkali metals, and group 2 metals are called alkaline earth metals. Okay, or alkaline metals. Then all group 2 metals means alkaline, that is given +2 oxidation state. This you have to consider. What is the standard you should know, just like oxygen -2. Like that way, group 1 all metals are given +1, and group 2 +2. Okay, group 3 +3. Okay, because you should know these are the fixed, but some are variable, you can't tell. That's why only oxidation number of variable oxidation states some element have variable oxidation state. As for example, transition metals, variables. That's why it is calculated oxidation number of this transition elements. Generally it is calculated, or that type of elements whose oxidation number is different. They can have more than one oxidation state. Then now Mg3N2 you compare, Mg was 0 and now Mg became plus 2. Mg3N2, then Mg became now plus 2, and nitrogen became minus 3. How? Then you can just simply calculate. Magnesium, you know, it is a plus 2. Then 3 magnesium is there, Mg3N2. Then 1 magnesium plus 2. Then 3 magnesium plus 6. Okay. And plus nitrogen you have to add. Then 1 nitrogen means minus, that is, suppose you are not knowing N2. N2 means 2N. Then you can calculate. Magnesium you are knowing, magnesium is plus 2, then 3 magnesium means 2 into 3. 2 into 3 plus, in bracket you don't know, N2 is there, means 2N. Then write only 2N. Okay, that is equal to finally 0, because Mg3N2 no charge is written, neither positive nor negative. Then it is 0. It means that is equal to 0. If in any molecule some charge is given, then equal to that charge, equal to whatever charge is there you have to write. But here nothing is written, means 0. Then now it became what? Mg3. Mg3 means 6. 2 into 3, 6. 6 plus 2N. 6 plus 2N. That is equal to 0. Then now you can get easily value of N. Then 2N is equal to minus 6. Plus 6 was there, you can take to the right side. Then now 2N is equal to plus 6. Minus 6. 2N is equal to minus 6, because magnesium was plus 6. You have brought right side. Then minus 6. 2N is equal to minus 6. Then N is equal to how much? Minus 6 divided by 2 means minus 3. Hence oxidation number of nitrogen is minus 3 in Mg3N2. In this product, magnesium has plus 2 and nitrogen has minus 3. Then now you compare, magnesium was in reactant side, magnesium was having 0 oxidation state. Now magnesium got plus 2. Magnesium 0 now converted to magnesium plus 2. 2 electron lost. And oxygen, nitrogen, which was 0, now it is minus 3. It means that magnesium lost how many electrons? Mg3. 1 magnesium given 2 electron, then 3 magnesium was there, then 6 electron it lost. 6 electron it lost. Who have taken this 6 electron? Then nitrogen was having 0. Now it is becoming 1 atom, that is a minus 3. Then Mg3N2, then minus 3 into 2 minus 6. It means 6 electron magnesium lost, and this 6 electron nitrogen got. Then here you have seen there was change in oxidation state. Magnesium, it became from 0 to plus 2, and nitrogen from 0 to minus 3. Hence this is also a redox reaction. Same way you can calculate for any other reaction if you have to prove whether it is a redox reaction or not. If there is a change, then certainly it is redox reaction. If there is no change, as it is, what was the you can say left side, and same thing is for right side, means reactant and product side, both side atom has, after comparing, there is no change, then it means that is the not the redox reaction. If change only, then redox reaction. If there is no change, then no redox reaction. Then now third one you can see CH4 plus 2O2. It is giving CO2 plus 2H2O. CO2 plus 2H2O, this is the product. Then same way what I have discussed for CH4, then for H you know, for again you know, hydrogen has in general plus 1 oxidation state, plus 1. These are the common things you have to understand. Hydrogen has plus 1 state. Then obviously CH4 means plus 4 is there. Then obviously carbon will be minus 4. Minus 4. Then in this carbon has minus 4. In CH4 carbon has minus 4 and hydrogen has plus 1. Okay, plus 1. Just you have to write on the head of each atom. Then CH4 you have written for carbon minus 4 and hydrogen plus 1. Now 2O2. Then now O2 is there. Then O2 means 0. O2 means 0. Now product side CO2. Then now already know that oxygen is CO2. Per atom you have to write. Per atom. Then CO2 means oxygen has minus 2. Minus 2. Then and carbon has plus 4. Carbon has plus, because minus 2 one atom is there. Then CO2 2 atoms are there. Then minus, total minus 4. Then carbon will have plus 4. Plus 4. Then in CO2 carbon has plus 4 and oxygen has minus 2. Then now if you will compare, then reactant side carbon was having minus 4. Minus 4. Now product side CO2, now it is plus 4. Then see, there is a change from minus 4 to plus 4. It was minus 4, now it became plus 4. Then 100% it is redox reaction. Other you compare hydrogen, then hydrogen I will compare you. But before that oxygen you compare, because hydrogen and 2H2O it formed, I will tell you. Then for oxygen you can see, then oxygen was 0, now oxygen became a minus 2 in CO2. Then again there is a change, then that's why it is redox reaction. Now this hydrogen you compare, then 2H2O. 2H2O, second product was 2H2O. Then H2O know that it is the plus 1. Plus 1 and oxygen is minus 2. Minus 2. And this is well known. Then hydrogen if you will compare, then hydrogen was plus 1 in CH4 and product side 2H2O. There also, because oxygen is minus 2, then obviously 2H2O is there, 2H2O. Then oxygen is minus 2. Then 2H2O. 2H2O was there, then 2 into 2, 4. Minus 4 total oxygen is there. Then here oxygen is minus 4 total, minus 4. Then hydrogen 2H2. Then obviously 4 hydrogen is there. Then how they will balance? Then they have to neutralize. Then minus 4 is there. Then total hydrogen will be plus 4. Then 4 hydrogen is there. Then each atom, 1 hydrogen, 1 plus charge, 4 hydrogen, 2H2 means 4 hydrogen is there. Then each hydrogen plus 1. Hence oxidation number is plus 1 in water, in H2O, right side. Then for if you will compare hydrogen, then hydrogen both side equal. Plus 1 is here also, right left side, reactant side plus 1 and product side also plus 1. Hence In this case, there is a no change. For hydrogen, there is a no change, and change is only for carbon. -4 became +4. Oxygen was 0, that became in CO2 it became -2, and in H2O it became -2. Okay, like that way, because there is a change in oxidation number, that's why it is a redox reaction. Okay, anywhere it is left side, right side, there must be at least in any atom one change should be there, at least. Then only you can tell that it is a redox reaction. If no change at all, then no redox reaction. Then this I have told about the combination reaction, just like addition. Now just to come to the second type, decomposition reaction. Decomposition reaction. Then here you can see decomposition reactions are the opposite of combination, because it is related to breaking. It is breaking. Reverse of combination is called decomposition. Name itself is there. Decomposition. Decomposition means breaking. It will break it. Decomposition reactions are the opposite of combination reactions. Precisely, a decomposition reaction leads to the breakdown of compound into two or more components, at least one of which must be in the elemental state. Okay, suppose it is breaking in 2 and 3 parts, then out of 3 or 2, whatever be, at least one should be in elemental part. Examples I am telling you. Then here, just to understand, 2H2O, when it will break, it will form H2 plus O2. Correct? When H2O means how much? 2H2 means 4 hydrogen and 2 oxygen atom. 4 hydrogen atom, 2 oxygen atom. Then 4 hydrogen atom means 2 H2 molecule. It will form 2 H2 molecule, and 2O means O2. Then decomposition of H2O, it gives 2 H2 plus O2. Both are gas. But water is liquid. It means 2 H2O liquid. It will give 2 H2 plus O2. Both are gas. Then now just to see decomposition reaction. This is called decomposition, because it was formed, water forms from oxygen and hydrogen. You know all the things. Water forms from oxygen and nitrogen. That's why after breaking it is giving hydrogen and oxygen. Okay, that's why its name is decomposition. Then now you compare oxidation number to check it whether it is a redox reaction or not. Then you can see here 2H2O. Then you know that a hydrogen is a +1 state and oxygen is -2. Obviously, by seeing the things you can tell, because its value is fixed. Hydrogen means +1, oxygen means -2. But here you can see right side, hydrogen gas is there. It means 0. Oxidation number of hydrogen gas is 0. Oxygen gas is also 0. Then if you will compare both side atom wise, then now we will see hydrogen was +1. Now it became 0. Means there is a change in oxidation number. That's why it is a redox reaction. And oxygen, it was -2. Now oxygen became 0. Right side after decomposition. Hence here also there is a change in oxidation number. Hence this is also redox reaction. Now another important reaction, hydride, sodium hydride, NaH, 2 NaH, it is giving 2 sodium plus H2. 2 sodium plus H2 after breaking. Means here decomposition means always you have to heat it, a strong heating. Okay, Then now sodium hydride is there, NaH. Here you should keep in mind, whenever hydrogen will be in the form of hydride, that time it will be -1. This is exception. Hydride is exception. There hydrogen will have -1, means when it will be in a hydride condition, they are taking 1 electron. But in other way, otherwise, in every case it will give. That is a general. But is the exception. Sometimes it will take also. Then taking means, because it is taking electron, that's why it is minus. 1 electron is taking, that's why 1 minus. Then here 2NaH balanced equation you will write, then 2Na plus H2. Then now already you know sodium has +1. Sodium belongs to first group. Hence in sodium will have alkali group +1 and hydrogen -1. Hydrogen -1 in hydride NaH. Sodium has +1, hydrogen has -1. But this side, right side means product side, sodium is in metal, then metal has elemental has a 0 oxidation number. And hydrogen gas, it is forming hydrogen gas, again 0. Then now we compare, sodium it was +1, now it became 0, means there is a change in oxidation number. That's why it is a redox reaction. Hydrogen -1, now it became 0. Hence there is a change in oxidation number. That's why it is a redox reaction. Now third example I am telling you. Potassium chlorate, KClO3, potassium chlorate, after decomposition means a strong heating, it will form potassium chloride and oxygen. This is also, you remember, these type of reactions are common. Then potassium chlorate, when it is heated, it will form potassium chloride plus oxygen. Balance equation you can write like this: 2KClO3. 2KClO3, that is a solid actually, S you can write in a small bracket. When you will heat potassium chlorate, it will give potassium chlorate. Heating means triangle sign will be there. That above the arrow sign you can write a small triangle. It means this triangle sign is telling about you are heating. Okay. Then 2KClO3 you can write a arrow sign, and above the arrow sign a small triangle you write. That means heating. Then potassium chloride means 2KClO3. When you are heating, it is giving 2KCl plus 3O2. It is a balanced equation. 2KCl plus 3O2. Now you write this thing, oxidation number, atom wise. Left side also, right side also, means reactant side also, product side also. Then KCl. Then K belongs to alkali group. It means it has +1 oxidation state. And chloride ion, see, all you can say halogen group, they are variable. Generally they want only 1 electron. But they may have variable oxidation state. Then you have to calculate all variable atoms or elements. You have to calculate atom of elements, same element. Then here 2 KCl is there. The K you are knowing that it is a +1, and KClO3, then because Cl is variable, hence you have to calculate for Cl. O3, KClO3 is oxygen, you know that oxygen is -2. Then easily you can calculate K is KClO3. Then K means +1. K means +1 in bracket you can write. Plus atom wise you write in bracket, atom wise. Then K means plus 1 in bracket. Again plus. This you have to calculate. Chlorine you have to calculate. KClO3, 1 Cl is there, then Cl only you write in bracket. Plus O3, 3 O is there, then 3 minus 2. Because each oxygen has minus 2. Then in bracket you write 3 minus 2. Finally, no charge is KClO3. No charge is there, no negative, no positive. It means it is a 0. It means that's why you can write here equal to 0. Then 1 plus Cl minus 6, that is equal to 0. 1 plus Cl you want to calculate, and you can write Cl or X, anything you can consider. Cl only you write. Chlorine you want, what is the value of this chloride, that you have to calculate. Oxidation state, hence you write Cl only. Then 1 plus 6, 1 plus Cl minus 6, that is equal to 0. Then now plus 1 is there and minus 6 is there, means minus 5. Then Cl minus 5 is equal to 0. It means Cl is equal to plus 5. Then now you have calculated oxidation number of chloride. Then now you write here 5 above the head, above the chlorine you written, that you write plus 5. Then now KClO3, for K already we are knowing plus 1, oxygen was minus 2, now you calculated Cl plus 5. Now right side, product side, KCl is there, then again KCl is there, means K is plus 1, and because KCl is there, then K is plus 1. Then now you have to neutralize, because finally you have to bring 0, because KCl no charge they have written. It means it should be 0. Then K is plus 1, then Cl will be minus 1 in this molecule. In KCl, K will be plus 1. Then obviously Cl will be minus 1, because charge you have to neutralize. Because in KCl there nothing is written, means it is 0. Then K is plus 1, it means Cl will be minus 1. Easily you can calculate and write. Then now for oxygen, 3O2, he has given oxygen gas. If you will heat potassium chloride, you will get oxygen gas. Main product is oxygen gas. And potassium chloride is also there, but potassium chlorate is heated to get oxygen gas. Okay. Then now O2, 3O2 product is there. Then O2 means gas is there. Then O2, oxidation number of O2, 0. Oxidation number of O2 is equal to 0, because it is in gaseous state. Now if you will compare whether it is a redox reaction or not, then easily you can calculate, compare. Then reactant side potassium was plus 1, product side also plus 1. Hence no oxidation change. Oxidation number is not changed. And chlorine you can see, chlorine Cl, okay. Then it was 5, right side it was 5, and left side with KCl it became minus 1. Then here it is a change, here it is a change, plus 5, now it became minus 1. Hence redox reaction took place. Anywhere at least one change should be there. Then reaction is redox reaction. Then by comparing chlorine atom, now you got there is a change. Oxygen, it was minus 2, now this side became 0. This side became 0. It means here also change took place. Minus 2 became 0. Okay. Actually, if you calculate, then left side and right side charge will be equal. Charge will be equal. Okay, but better what I told you, you consider like that. Atom molecule wise only you think. Molecule wise only you think. Okay. Now, actually some ionic reactions are there. There you have to learn how to balance it. Okay. Then left left side means this side, right hand side and left hand side charge must be equal. Charge always must be equal, negative and positive. Then it will be equal, means number of electrons or number of positive charge, number of negative charge must be equal. Okay. Then everywhere this concept will be applied. Then now here I told you 3 reaction about the decomposition reaction, and you have proved also that this is the redox reaction. Then second type of redox reaction is decomposition reaction. It may carefully be noted that there is no change in the oxidation number of hydrogen in methane. Okay, already I told you, under combination reaction, and that of potassium in potassium chlorate. Okay, these things already I have told you. And also should know that all decomposition reactions are not redox reaction. Very important thing. Exception and question is asked. Okay, question will be asked either in mains or in advance or any general examination also. Okay, because it is interesting that all decomposition reactions are not redox reaction. For example, decomposition of calcium carbonate. Best example is calcium carbonate. Calcium carbonate is not a redox reaction. How will you prove? Then first write the balance equation. Then calcium carbonate, this is a solid. Calcium carbonate, in white washing in Deepavali time, white chalk like that, all are calcium carbonate, a stone. Then calcium carbonate, this is a solid, it will give calcium oxide, CaO, solid, and it will give carbon dioxide gas also. Means calcium carbonate, after heating, it will give 2 products. First product is calcium oxide, second product is carbon dioxide gas. Okay, then now here you have to prove that this is not the redox reaction. How will you prove? Then only one way is there, that atom wise, first to write oxidation number, both side, reactant side, product side, atom wise you write oxidation number, and then you compare. Then now here calcium, calcium belong to the second group. It means it has oxidation number +2. These are the fixed things. You have to not bother. You have to write what you know. Only which can change, as I told you, like a chlorine atom. Chlorine, there it is chlorine, fluorine, iodine, fluorine, all halogens, they are changing. And metal, sometimes it will change, particularly transition metals. For that you can't tell anything. But which is fixed, that you have to not bother. Then calcium, barium, all things are strontium +2. It is fixed. Then calcium carbonate, calcium is +2. Okay. And carbon is also variable. And oxygen is not variable. Oxygen also some fixed value is there according to molecules, but sometimes -1 also it may be there. But particularly in peroxide, it may be in fraction also. But here, in generally, it will be -2. Okay. Then calcium carbonate, then calcium +2. You write on the head of calcium +2, and oxygen you write -2. Then now carbon you don't know because it is variable. What will be the value? Then now you can easily calculate calcium carbonate CaCO3, the +2 in one bracket. Again plus carbon you want to calculate, write C in bracket, or +C plus CaCO3, 3 oxygen are there, oxygen is there, oxygen atom, then 3 minus 2 in bracket you write, that is equal to 0. That is equal to 0 because no charge is there. Then Ca, for the Ca you have written 2 plus carbon you want to calculate, plus in bracket 3 minus 2, that is equal to 0, means 3 minus 2 means 6. Then now we got plus 2 plus carbon minus 6, that is equal to 0. Then C minus 4 is equal to 0. C minus 4 is equal to 0. It means C is equal to plus 4. Then now plus 4 you write on the head of carbon. Plus 4 you calculated. Plus 4. Okay. If out of 3, 2 value of 2 things you are knowing, third easily you can calculate because total is 0. Total is 0. Then you calculated plus 4. Now calcium oxide you can see. Calcium oxide, you know, both are standard. Calcium is a plus 2, oxygen is minus 2. Okay. And in CO2, then oxygen is minus 2, you know, then 2 oxygen is there. It minus, total charge is minus 4. Then carbon you will have plus 4. Carbon will have plus 4. In CO2, carbon has plus 4 and oxygen, one oxygen atom, minus 2. What you are writing now, oxidation number, that is for single atom. But this calculating time O2 you are considering. O2 or total number of atoms. Total number of atoms you are calculating. Then now you compare. Then what you will get? Calcium was plus 2, reactant side, and product side also plus 2. Then no change in oxidation number. Carbon was plus 4, a reactant side, CO3, carbon was plus 4. And here, product side CO2 formed, there also it is plus 4. Then no change in oxidation number. Oxygen was in CO3, oxygen was minus 2. And product side with CO2, it is also minus 2. Then in no atom there is a change in oxidation number, no change in oxidation number at all. Hence this reaction gone, but it is not the redox reaction. This is not the redox reaction. This example always you keep in mind because it is exception. Exception questions always in examination is asked. Then how I have told you about the, you can say, decomposition reaction. 3-4 example I have given you. Now come to the displacement reaction. Displacement, by name itself it is clear. Displaced. Suppose you were I can say in a group. Suppose there was a group of 4 members and other group also had 4 members. 2 group was there. In first group 4 member, second group 4 member. Now what happened? Just one person exchanged. Means you went to other group and one person from the other came to your place. Then that is, you can tell, displacement. Okay, that one person came from group 2 to group 1 and other person went from group 1 to group 2. Exchange. That is actually called displacement. Then this is the general meaning I told you for the displacement. Now just reaction wise you can understand. In a displacement reaction, an ion or an atom in a compound is replaced. Okay, one will go other will come here, like that way. Replaced. Okay, is replaced by an ion or an atom. Same type of atom or ion will be replaced. Same type I am talking about, not the same. Why will the same means why they will change? Okay, similarity will be there. Similarity will be there. Okay, suppose one ion went, that was the negative, one negative. Then that anion went, and similar type of another anion came which was having only one negative also. And then charge was not difference would be there. Okay, and calcium suppose 2 plus went, then 2 positive went, then one went, other will come, that will also have 2 positive, like a barium. The only inequality exchange will be only in equality. Replacement will be inequality. Then this you keep in mind that in a displacement reaction, an ion or an atom in a compound is replaced by an ion or an atom of another element. Then in general we can understand X plus YZ. X is the one element, one atom, and plus YZ. YZ is a compound. YZ is a compound. Then X plus YZ. Then now with the Z, Y is there. Now YZ compound is there. Then YZ has. Now Y is going to be replaced. In the place of Y, X has come. And Y has went to the X position. Then now new compound you got XZ. XZ. Correct? And Y went to the place of X. Okay. Then this is called displacement reaction. Now I am giving example, exact example I am giving you now. Copper sulfate, CuSO4, copper sulfate solution, aqueous means CuSO4 AQ. CuSO4 solid is there, but reaction will take place in always 99.9%. Reaction takes place in solid liquid state, always in liquid state. That's why AQ word is used, aqueous. Then here I told you there are two type of displacement, reaction. Then first, that is the metal displacement, and second type is a non-metal displacement. Okay. Then now I am giving example of metal displacement. Then copper sulfate, CuSO4 solution means aqueous. CuSO4 in bracket, a small bracket, you guys, AQ means aqueous. Then CuSO4 plus Zn, both will react. Reactant side is copper sulfate plus Zn, zinc. And product side now, see there is a displacement. Now copper sulfate, then with the sulfate copper was there. Then reaction is going on copper sulfate plus Zn. Then now this copper in copper sulfate, that copper sulfate will go, and in the place of copper Zn came. Then now new product form is ZnSO4, zinc sulfate, and this copper is replaced. They went for in the place of Zn, copper. Okay. Then copper sulfate plus Zn means ZnSO4 plus copper. This is the balanced equation. CuSO4 plus Zn. Then now Zn came in the place of copper, and copper went to the Zn place. Then now new product got ZnSO4 plus copper. Now you check it whether it is oxidation redox reaction or not. Then copper has plus 2. Here again I am telling you it is a metal, copper. Generally actually copper is also variable. Sometimes copper will be in a plus 2 state, sometimes plus 1 state. And sulfur also CuSO4. CuSO4 is there, then here you have to careful in calculating. Cu plus 2 SO4. Then oxygen is fixed, minus 2. Then here generally copper in a normal condition it will be plus 2. It will be CuO, means Cu, suppose cupric oxide is there, CuO, then O is minus 2, then copper will be plus 2. Other will be Cu2O, Cu down 2 and O. It means oxygen was 2 negative and 2 copper is there. That it means here 2 coppers are there, both are Cu plus 1, Cu plus 1. That's why charge is neutralized. 2 positive charge, each copper has 1 positive. Then 2 positive is neutralized by 2 negative. Oxygen has minus 2, hence Cu2O. Then Cu plus, less is called Us, more is called Ik. Then CuO, that was the cupric oxide, and here Cu2O, cuprous oxide. Then here in CuSO4, Cu plus S, both are variable. Oxygen is 99% it is fixed, okay, minus 2. Then sulfur is more variable. You have to compare both copper and sulfur, both are variable, but sulfur is more variable. Hence you can consider copper as a standard, then plus 2 you can consider. Copper has plus 2. Then now copper you are knowing plus 2 and oxygen is minus 2, then easily you can calculate sulfur. What is oxidation number of sulfur? Then CuSO4, Cu means plus 2. Plus 2 plus sulfur you don't know, write sulfur only. Means 2 plus S plus oxygen is here 4. Then 4 minus 2, 8. 4 minus 2 minus 8, that is equal to 0. Then 2 plus S minus 8, that is equal to 0. It means S minus 6 is equal to 0. Then S is equal to 1 minute. 2 copper is 2 and oxygen is SO4, no? Then 4 minus 8 and copper is plus 2 then 1 minute here, CuSO4, okay, copper plus 2 consider and oxygen minus 2. Then here what you will get, 4 minus 2 minus 8 and minus 8 plus 2, then plus 6. Then here you can see sulfur should come plus 6 in general way, but here sulfur has changed, okay. That you will calculate by seeing the products, only you can tell very correctly for the sulfur. Then now you can see here CuSO4. Now it is converted as CuSO4 plus Zn. Then Zn is equal to 0. Zn is elemental state, that is equal to 0, and product side copper is 0. Copper form, and that is also 0. And here it form ZnSO4, product side. Then by both sides we have to see, then copper situation will be clear. Then Zn is plus 2. ZnSO4, Zn is plus 2 and oxygen is also minus 2. Then now if you will calculate sulfur, then what value will come? Then value of ZnSO4, Zn is equal to 2 plus 2, then 2 plus S minus 8, that is equal to 0, means it will come S is equal to 6 plus 6, okay. Then right side 6 is there, sulfur is plus 6, then here also it is plus 6. You calculate, then that time also it will come CuSO4, then 2 plus S plus minus 8, that is equal to 0. Then S is equal to plus 6. And this side also S is equal to plus 6. It means now we compare atom wise. Then copper was plus 2. Now copper became 0. Copper in CuSO4 copper is plus 2. And product side copper is 0. Then there is a plus 2 became 0. It means there is a change in oxidation number. Oxidation number changed. And sulfur will compare, then no change. Plus 4, plus 6 and plus 6. Both side 6 is there. Hence there is no change in sulfur oxidation number. Okay. And this oxygen was minus 2. Oxygen was minus 2. Again here oxygen is minus 2. No change. And Zn also, I told you copper was plus 2. This copper was plus 2. Copper became, this side, right side, copper became 0. There is a change in copper oxidation number. And in sulfur there is a no change. Oxygen there is a no change. Okay, only change is in copper. That's why it is also, you can tell this is also redox reaction, and because here metal is involved, metal is going to be displaced. That's why it is called metal displacement. Okay, redox reaction. Now another example you can see, V2O5 vanadium pentoxide plus calcium, 5 calcium, balanced equation I am telling you. V2O5 means vanadium pentoxide, it is a solid, S you can write in bracket, plus 5 calcium, calcium is also solid in bracket, you can write, and product is 2 vanadium plus 5 CaO, 5 calcium oxide. It is a balanced equation. V2O5 plus 5 CaO, product is, after heating, it is giving 2V, mean 2 vanadium, capital B, plus 5 calcium oxide. Then now if you will write the oxidation number atom wise, then vanadium is plus 5. Same way you can calculate what I told you, same way. That is left for you. Many cases I told you, now you can calculate. Then V will come, V2O5. V2O5, you know that oxygen is minus 2 and 5 is there. Then minus 10. Then 2V is equal to minus 10. 2V minus 10 is equal to 0. 2V minus 10 is equal to 0. Then 2V is equal to 10. Then V is equal to 5. Like that we can calculate. Then now here vanadium is plus 5, oxygen is minus 2. Plus calcium. Calcium is 0 because it is elemental state. Product side, it is making vanadium 2B. Solid it is making. Then it is also 0. Oxidation number. And calcium oxide 5 CaO. Then oxygen is minus 2 and calcium is plus 2. Then now if we will compare, then we will find vanadium plus 5. Now it is becoming 0. It means this is a redox reaction. Okay, oxygen is no change. Only metal change is there. There is change in metal. Here also, if the first case we have seen, copper was plus 2, that converted into copper, only copper metal. After the displacement, that was the 0. Okay, that's why here V2O5 converting into 2V means V is 0. Hence plus 5 is converting to 0. Then there is a redox reaction. Oxygen is the same, both right side, left side, oxygen is the same. Okay, and calcium also was 0, but calcium also change is there. 5 Ca was 0, reactant side, and here CaO they formed, product side. Then here plus 2. Then calcium oxidation number also changed. Hence this is a 100% redox reaction. Like that way, thallium tetrachloride TlCl4, thallium Tl, symbol is Tl, it is uncommon, TlCl4, thallium chloride or thallium tetrachloride plus magnesium, it is forming thallium solid, it is forming thallium solid means metal plus MgCl2. Now like that way you can calculate very easily TlCl4, Cl is -1. Generally halogen will be -1, but it is variable. Then TlCl4 means -4 is there, then obviously Tl will have +4. Magnesium 2 Mg metal is there, then magnesium will be 0. Right side it is forming thallium, that is a 0. Magnesium chloride Cl2 means 2 minus is there, then obviously magnesium will be +2. If you will compare, then you find thallium +4 is converting into thallium 0, means there is a change in oxidation number. Magnesium was 0, now it become +2. It means there is change in oxidation number. Chloride was -1, right side, left side also -1, means there is no change in chlorine atom oxidation number. But other are changing, thallium is changing, calcium is changing. That's why it is oxidation, redox oxidation. Like that way, one more example I am telling you. That is the chromium oxide Cr2O3 plus 2Al, aluminum. This is important reaction. Cr2O3 plus 2Al. Product after heating it will give Al2O3 solid plus chromium sulfide 2Cr. Cr2O3 plus 2Al, it is giving Al2O3 plus 2Cr on heating. All three examples what I told, you are heating. Okay. Then like that way if you will calculate, then chromium oxide Cr2O3, oxygen will be -2, chromium will become +3. Aluminum is there, metal, that's why 0. Aluminum oxide, if you will calculate Al2O3, oxygen is -2, aluminum will become +3, and chromium metal is there, that's why 0. If you will compare, then you can see chromium was +3, now here chromium is becoming 0, from +3 to 0, product side, hence redox reaction. Oxygen was -2 and aluminum oxide product side also -2, hence in that no change. And aluminum 2Al reactant side, that was 0, now product side Al2O3, that way aluminum is +3, hence there is a change in oxidation number, hence this is a redox reaction. Okay, today I am stopping only here. I will continue now. This non-metal displacement plus another is there. Next class I will continue. Okay, thank you.